In this video, we're going to look at 5 different ways the cloud is being enhanced with technologies for performance: fog computing, edge computing, serverless architecture, services integration, and resource policies. Let's get started. Fog computing, also known as fogging, is the cloud plus the Internet of Things. Fog is a new distributed architecture that extends services offered in the cloud to edge devices. Fog nodes are made up of intelligence, computing power, and storage resources. This can be in the form of routers or smart gateways that communicate with the cloud. These fog nodes might, for example, process signals coming in from sensors in a certain part of a city to measure CO2 emissions and then send alerts. Edge devices are designed to accomplish specific tasks using apps. They come in all shapes and sizes, from smartwatches to autonomous cars to smart buildings. Edge devices can also be routers, switches, or firewalls. Fog computing uses decentralized local network architectures to speed up the analysis and retrieval of data near the source. With growing 5G wireless networking and embedded artificial intelligence, we're about to have billions of apps and devices coming online and a tsunami of data that needs to be processed. Fog can help with that. With fog, critical core functions are distributed. Computing, communications, control, storage, and decision-making are all close to where the data originates locally. Smart devices and sensors are being developed so the components can instantly interact via wireless networks. Since fog nodes are physically closer to devices in the network, users can enjoy much lower latency with instant responses to their computing needs. Fog provides greater security mainly because the data travels a much shorter distance in a distributed network. With fog, the storage capacity of the cloud is also enhanced. For example, a smart vehicle in trial right now is currently generating 35 gigabytes of data per hour. Secure fog computing has the power and reach to process this amount of data. In addition, fog has the monitoring, detecting, and reporting capabilities to provide real-time incident response for security breaches, allowing it to quickly detect and isolate threats and minimize disruption of services. While fog computing has many positive aspects, it also inherits a cornucopia of security issues from cloud computing: account hijacking, denial of service, access control issues, unsecure APIs, system and application vulnerabilities, shared technology issues, and much more. Now let's discuss edge computing. Edge computing is performed at or near the source of the data, not in the cloud. It's a component of fog computing where the architecture is distributed with decentralized processing power. We capture, store, process, and analyze the data near the client, where the data is usually generated. From the wearable on your wrist to streaming video optimization, from controlling intersection traffic flow to smart homes and buildings, edge computing's future is exponentially expanding with the Internet of Everything, artificial intelligence, 5G, robotics, machine learning, and all of the other technological developments taking place now. For edge devices to be smart, they must look at incoming data, process it effectively, share it, and take some sort of action. Edge computing means the edge devices take these actions without requiring data to be transported elsewhere. Using a hub and spoke model, the cloud is the hub and everything outside the spokes is the edge, like a spider web. Think of it like this. Edge computing is about processing the data locally, where cloud computing is focused on processing data in a remote data center that's a public or private cloud. There are many benefits of edge computing, and much like fog computing, these include lower latency, increased bandwidth, greater resiliency, and data sovereignty. Data sovereignty is the ability to own and manage your own data, and companies are very concerned about making sure their data remains theirs, regardless of the technology they utilize. Edge also empowers workloads that need processing in near real time, like autonomous cars communicating with each other. This speed and efficiency allows organizations to make more impactful and timely decisions, which reduces costs, help them better engage with customers, and increases privacy. Edge computing also suffers from many of the same security risks as fog and cloud computing. Another way to enhance cloud performance is by using serverless architecture or serverless computing. It lets you build and run your apps and services without having to actually manage the infrastructure they run on. Yes, your apps are still running on a server, but you don't have to take care of it or its components. Instead, your cloud provider takes care of all of the server provisioning management, leaving your developers to focus on what they do best, creating their core product. And this saves them precious time and energy. Basically, a serverless architecture eliminates most of the infrastructure management tasks of server provisioning, patching, OS and database maintenance, storage, and more. The cloud service provider takes care of fault tolerance and high availability. Ultimately, serverless architecture reduces costs and frees the company and its developers to focus on product innovation and a faster time to market. This gives them great agility and responsiveness while they enjoy automatic application scaling and market competitiveness. The serverless model is often referred to as backend as a service or BaaS, meaning that companies simply pay for the resources consumed on the back end. Companies can also rent functions and compute runtimes, known as function as a service or FaaS. This allows companies to execute application logic, but none of their data is stored. Major FaaS vendors are Amazon, Google, IBM, and Microsoft. Benefits of cloud services integration include synchronized data and apps, increased agility, faster time to market, improved operational efficiency, reduced operational costs, increased flexibility, and scalability. Whether single cloud or multi-cloud focused, businesses are enjoying the tremendous feature-rich benefits of cloud services integration. While there are many positive aspects to serverless, there are also a few drawbacks. The first is performance. Some code could suffer from latency because the cloud provider typically spins down the serverless code while it's not in use. If the code you need has to take time to start up, that will cause a delay. Also, serverless may not be appropriate for some workloads, like high-performance computing due to resource limits. The next drawback is security. In serverless computing, the total attack surface is due to each component being an entry point to the serverless application. Some of these would include network sniffing, man-in-the-middle attack, phishing, SQL injection, DDoS, and code exploit. Further, because of limitations, companies can't implement an intrusion detection prevention system or IDS/IPS. The next challenge is privacy. Many serverless environments use proprietary public cloud environments, and resources are often shared. To overcome this, serverless computing can be done on private clouds or even on premises, which allows companies full control over system privacy. Integration with the cloud has really grown in popularity as software as a service solutions continue to increase. Many more businesses are running a hybrid mix of on-premises apps and SaaS apps, and this is creating a much greater need for innovative integration methods. There are three major integration types of cloud technologies: cloud to cloud, cloud to on-prem, and a hybrid combination of the two. Data and app integration needs are the core concern when you're choosing from these strategies. Businesses can build their own integration solutions for their enterprise, or they can employ a third-party provider with a solution that's reusable, agile, and scalable. More than likely, integrating with the cloud could be far more cost-effective as well. However, data and apps need to be protected from internal and external threats. Misconfigurations can open devastating security vulnerabilities. A good cloud access security broker, or CASB, can be a dedicated security solution that monitors and automates security configuration audits. A resource policy is attached to a specific resource where you can specify who has access to it and what they can do with it. This helps to lock down applications and data on mobile devices and integrate with cloud resources. You can create policies in something like Microsoft Intune and then roll them out to all your users. This includes your users who would like to bring your own device, or BYOD. You can keep your corporate apps and data secure and encrypted on these devices, regardless of the OS, Android, iOS, or Windows. Policies are usually applied to groups of users or groups of devices. If you're using Microsoft Intune for your resource policies, you'll need to integrate with Azure Active Directory services in the Azure cloud. That's it for this lesson. In this lesson, we looked at other technologies that enhance cloud performance like fog computing, edge computing, and serverless architecture. We also discussed services integration and we ended by exploring resource policies. The cloud will continue to expand, and more options will become available to enhance its performance.